The Hubble Space Telescope, after all these years, still going where no man has gone before, opening up the universe, letting mankind peer into the unknown galaxies, beaming back spectacular images like this cluster of thousands of stars, the deepest images of space.
3, 2, 1, and liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
It was 25 years ago today that the Hubble blasted off on that journey attached to the Space Shuttle Discovery, the world watching that liftoff from Kennedy Space Center. Hello everyone, I'm Dan Pleffler in New York. Hubble, hailed by many as one of NASA's greatest achievements, giving man a set of eyes to see an unobstructed view of the universe. And on this very special day, I want to be bringing in our Jennifer Weissman. She is the Hubble Senior Project Scientist. Thank you so much for joining us and congratulations on this day.
My pleasure. Thank you.
Jennifer, any idea, April 24th, 1990, scientists around the world, especially here in the United States, have any clue that now 25 years later this creation would still be thriving and really bringing back these amazing images from space?
I think Hubble has gone beyond anybody's wildest expectations. You know, launching a telescope like this into space was a bit of an experiment. It wasn't the first telescope in space, but it was the first major observatory. It was put in space to get us above the atmosphere so we could get clear, unobscured images with sharp resolution. And Hubble has produced far more than we could ever have dreamed of. I mean, 25 years, I think that was not envisioned at first. But we've had a series of astronaut missions to Hubble that have kept it in tip-top shape. And I'm so pleased that Hubble is actually at the peak of its scientific performance and capabilities right now, even after 25 years.
And not only just the technological aspect for it, but just to get the support and the enthusiasm behind the project to begin with was a struggle, right?
That's right. I mean, the idea had actually been envisioned and promoted for some decades before the actual launch. And of course, it took quite a lot of effort to convince people that this was worth funding, that this was worth doing. And I'm so pleased that scientists and engineers and the public and the Congress all came together to support the idea of having this facility in space. Of course, if you recall, the first images from Hubble were disappointing back in 1990. There was a problem with the mirror, and that created an initial crisis with the observatory, but it actually turned out for great good because astronauts went up 3 years later, and through some innovative corrections, we got a telescope better than ever. And for the last year since 1993, since that repair, we've had just spectacular images and repeated servicing missions from astronauts that have kept our eye in the sky in great shape.
What did that do then, I guess, for morale and for trying to go forward then when those first couple of images that came back, they're not exactly what everyone had hoped for or expected?
Well, I think it was a big disappointment at first. You know, everyone was anticipating the greatest images ever, and they weren't. But it also helped people sharpen their pencils and really think about what we could do. And so, in fact, what happened in 1993 was that corrective optics were installed on the telescope. And subsequently, all the cameras and instruments we've put on Hubble have had their own corrections installed. So we get fabulous data. And because of that, Hubble gets these very sharp images and can see very sensitively into deep space. So thanks to those astronauts who've gone up repeatedly, we have a fabulous facility. We can see, differentiate star from star in very crowded clusters of stars. We even have instruments that can see infrared light to some extent, so we can see inside some of these dense interstellar clouds and find out how stars continue to form inside these dense nebulae. And we can even see very distant other galaxies. These galaxies are collections of hundreds of billions of stars, and Hubble is able to see some of the most distant galaxies in the universe. These are shining to us from the past, so it's really a time machine. We can see galaxies from sometimes billions of years away, light years away, which means we're seeing them as they were billions of years in the past, closer to the beginning of the universe. We can see how galaxies have changed over time as we compare distant galaxies to more nearby ones in our own. So Hubble has provided us not only a window into how space looks today, but also a window into time to see how space and how the universe has changed over time.
And speaking of our own galaxy, for a long period of time, anything that we knew about Pluto, essentially we learned from our school textbooks. 6 years after the launch, though, some of those first images, obviously the first ever to capture Pluto, and that was really a game changer, wasn't it?
Well, sure. Hubble has been instrumental in understanding our own solar system. We have used Hubble to look at many planets, moons, comets, asteroids. Pluto itself is interesting. It's an object in what we call the Kuiper belt, which we now know is very rich with rocky objects in the outer portions of our solar system. And Hubble has actually recently detected several previously undiscovered moons around Pluto. So this is interesting in its own right, but it's also helpful to us at NASA as we are preparing for a probe that's about to pass by Pluto later this year, the New Horizons mission. We're helping to chart its course based on Hubble's observations of where these moons and other rocky debris might be to make sure we chart an interesting and safe course for the New Horizons probe. So Hubble helps us to understand our own solar system and also helps us to understand how to use other facilities better to take the knowledge even deeper.
Because this is just such a mind-boggling venture, there is a lot of sort of fact and fiction information out there about Hubble. So I want to ask you a couple of true or false questions about Hubble. Clear this up for us if you can, all right? Okay. True or false on this one? Hubble only takes pictures in shades of black and white. Ah,
that's very good. So the data that we take with Hubble is often taken through certain filters that give us the specific kinds of information we're interested in while blocking out the kind of extraneous wavelengths of light that we're not interested in. But everything we get is on these digital detectors, which basically are seeing black and white. And so then to retranslate them into what the actual colors are, we put the colors of the filters that we know we've used back into the images so we can see the colors as they really ought to be.
Interesting. Okay, true or false on this one? The Hubble's so powerful it can spot the light of a firefly at a distance of 7,000 miles.
Well, we've never actually done the experiment of placing a firefly that far from Hubble to see what we can see, but it does have that kind of both sensitivity and also what we call angular resolution, so you can see things very, very sharply with Hubble. What that translates in, astronomically speaking, is that we can peer into, let's say, a very dense cluster of stars, and the light doesn't just get all meshed together. We can actually differentiate star from star. That helps us in astrophysics to understand populations of stars. We can see very clearly these interstellar clouds, these majestic pillars of gas, and see how the sharp edges of the gas differentiate from the less dense medium outside. We can even see details of atmospheres of planets in our solar system. These gorgeous images of, say, Jupiter that Hubble has returned tell us something about the different atmospheric layers of the planet. So it's that sharp angular resolution and that's high sensitivity that makes Hubble truly spectacular. And Hubble can also see colors of light that our eyes can't see. So that's a capability that helps us as well. Hubble can view not only visible light, but we can see light in ultraviolet wavelengths and infrared wavelengths of light. Many objects in space emit a lot of their information in these otherwise invisible colors, and yet Hubble reveals them. We can see things like aurorae on other planets and moons in our solar system. They mostly shine in ultraviolet light. We can see into some of these dense interstellar clouds and see baby stars as they form. We can see that in Hubble's infrared camera capabilities. Otherwise, these things would be hidden from our view.
Amazing accomplishments and obviously images over the past 25 years. So what is next? What does Hubble have its sights set on for the future?
Well, I am so pleased to say that right now Hubble is in great shape because the last servicing mission with astronauts in 2009 was so successful. We have healthy batteries, healthy gyroscopes that help us point the telescope, and a whole suite of fabulous cameras and spectrographs, scientific instruments on the observatory that are bringing us fabulous data even today. We expect that to continue for some years, so we don't see any reason why Hubble shouldn't continue to bring us this first-rate scientific return for several years. Our little slogan here is Hubble 2020 because we think Hubble will operate well at least to 2020 and probably for quite a few years beyond that. We're also thinking and planning about future observatories in space. Right now, NASA is planning a major space telescope to launch in 2018, which is called the James Webb Space Telescope. The Webb telescope will be attuned to infrared wavelengths of light. So while Hubble can see some into the infrared, the Webb telescope will see even farther into the infrared, can see deeper into these interstellar clouds and into these regions around stars where planets are forming. That will be so fascinating. And then it will also see very distant galaxies in the universe, even farther galaxies than Hubble can see. So we'll use these observatories. Hopefully they'll overlap some, and so we can use them in complement with each other. And NASA has other telescopes in space right now, the Chandra X-ray Observatory and the Spitzer Space Telescope, to name a couple. And we also work in concert with fabulous telescopes that are on the ground. So all of these work like a suite of instruments in an orchestra that give us beautiful music, if you will, beautiful information about the universe. And we're excited about what astronomy and space exploration holds for us in the years to come.
Keep them coming, because they've been delighting for 25 years. Jennifer Weissman at the Goddard Space Flight Center in Maryland, thank you. And again, congratulations on the historic day today.
Thank you.
You can keep up with this story in real time, downloading the ABC News app and starring the story for exclusive updates on the go.